Right, this is fully for me. Well, kind of. It's like everything I've learned in physics A-level so far, but in like more of a teachy format. So we have two teachers. One is doing topic 1, which is errors and uncertainty, and the other one is doing the start of particles. So I'll do both of those now, I guess. Or I'll do errors now and I'll do particles in a different one. So basically what I've learned in errors is completely from memory, so this will be kind of like a revision resource, but it'll be easier for you lot to learn because I'm teaching it back. So first of all, two types of errors: random and systematic. So basically a random error is something that changes every time, no pattern. It is stuff such as parabolic vision, stuff like say you have a ruler and your eye is here. Someone else may or may not be looking at from this angle and from this angle, and they will be able to see completely different places. Thus, that is the parabolic vision, which is like you just don't see the same. Systematic error, on the other hand, is an error which does not follow. No, it does follow a pattern. It is basically say you have weights. Then on said weight you put something like a person. You know that person weighs 79 kg, but on the scale it comes up with 82 kg. You know you have a systematic error because the scale isn't calibrated. Thus, coming into the process of calibration, which is the idea of factoring in these problems. Okay, what else have I done in errors and uncertainty? You're calculating uncertainty. So say you have the values. For A, you have the values 7.4, 7.7, and then 8.2. So these are three values. To calculate the uncertainty from these three values, you would do range over 2. So that would be 0.6, 0.8 over 2 equals 0.4, and that's plus or minus 0.4. So as a fraction, that would be, as a fraction is 0.4, so it is this. And as a percentage uncertainty, that would be 0.4 over, and it would be all of these values added up. So that would be the 7.4 plus 7.7 plus 8.2, and then that divided by 3. So that would be 7.76 recurring, and then that would equal 0.4 over answer times 100, which would be plus or minus 5.2% plus. So that is uncertainties. So now combining uncertainties. So say we obviously saw the uncertainty of A was 5.5%. Let's just leave it as that, 5.5%. Let's say the uncertainty of B was 7% and C was 2.5%. So to be able to solve stuff like A squared, it would be every time one of the letters show up, you just add its value. So this would be A times A, so it's shown up twice, so that would be 11. A over B, A shown up once, B shown up once, so that would be 5 plus 7, which would be 12, and then 0.5, 12.5. And then C, so C squared plus A squared plus B, that would be 2.5 plus 2.5 plus 5.5 plus 5.5 plus 7. Quick maths, 23. Look at that. So that would be combining uncertainties. Very simple, very easy. And now, the pinnacle of this, which is what I've done today, which is error bars. So basically error bars are things such as you have your normal line of best fit with values going through it. Then you have a steeper line of best fit, which would be close to the actual line of best fit, but would not exactly follow the same pattern. And there would be another value. This would be normally when you have error bars. So error bars would be, say you have 1 error bar, 2 error bar, 3 error bar, 4 error bar, and 5 error bar. So you want the values to go through as many of the error bars as possible. So obviously this one would try and go through the top, this one would try and go through the bottom, and then this one would go through the actual mean points, which would be that. And then you'd do the gradients. So for gradients in A level you use big triangles, and then let's just use a different color, and then there. So you use big triangles to be able to find out the gradient. So say there's a gradient there, there's a gradient there, and there's also a gradient there. And then you use them to find out the gradient, and then you were to do, say the gradient of the average one was 0.5, the steeper one was 0.7, and the shallow one was 0.6. 0.6, oh dear god, 0.4. Sure, let's just leave it as that. So for this, you'd obviously, for the average, you would do 0.7 plus 0.4 over 2 equals 0.7 plus 0.4 divided by 2 equals 0.55. So that would be the uncertainty here. And as far as the formula for the percentage uncertainty, it would be the best line of best fit minus the worst line of best fit over line of best fit times 100. 0.5 times minus 0.55. No, not times minus 0.5. What are you doing? 0.5. And then times 100. So that would be minus 10%. So that's plus or minus 10% would be the percentage uncertainty. So that is basically what we have done in physics so far. Yeah, that is actually probably about it. We have also done a little experiment, which is, say you have this tub, you have a tub of water, and you do that. So basically there's a human hand, and it picks up the tub and then drops it, and when it drops it, it creates waves. So we measured the time taken to get a certain distance, and then the distance changed, and we used to measure the times, and then we measured the times in a table, and then we drew a graph to depict our results, and then we had a little test on it. So basically that is all of the error stuff we have done so far in A-level physics. And now for particle physics, which would be out before or after this, depending on whatever I do.